All right, happy Friday, everybody. Um, this is the second episode of our study sessions, and for those that don't know, my name is Lee Douglas from Cool IT, and I'm pretty much just leading the study session, right? So the structure of this is that we just run through the exam objectives that CompTIA Security Plus SY0-701 Exam has laid out for everybody, and then from there we just go through each bullet point. We'll Google it and we'll try to explain each and every point as we go through it, right? So I'm not saying that this is official or um how do I want to put it? It's basically just free game, right? I've already passed the Security Plus exam and I think it's beneficial to study with somebody that has already passed and is in the field. So I'm just going to be running through and giving you my interpretation. And then I'm going to be looking at Google's interpretation. And if it's something that I haven't used before, I'll be honest and say I haven't used it. Um, my background is that I'm an HSM engineer. I've had the A plus, Security Plus, Net Plus, AWS, and AWS Solutions Architect Associate certification. So I'm pretty good at test taking. And pretty much what I do is my process is that I'll just read about it. I'll try to teach it to someone and then I'll write it down over and over until I pass the exam. Really simple and just letting you in on my study process. All right, now that we got that out the way, we can hop right into section 1.2 of the exam. So they're asking us to summarize fundamental security concepts. All right, so we talked a little bit about yesterday we talked about section 1.1 where we compared and contrasted various types of security controls. I also introduced the concepts of the CIA triad. So with the CIA triad, you have these the C, which would be confidentiality, and that's basically when we having a conversation, we're exchanging information, and that information should only be between me, the sender, and you, the receiver, right? So we don't want anybody else in our conversation. That's confidentiality. Then you have integrity, the I of the CIA. Integrity means when I send you a message, right? Like let's say I'm sending you an email, I wanted to say exactly what I intended it to say, right? So if I sent a message saying I love you to you, it should say I love you when you get there and not I hate you, because then that could start a whole war or a whole problem for me. So we want integrity there. Then we also want availability, right? So imagine I'm trying to send you a message, but you can't get it because your network is down. Then you're not available. And that's kind of a security issue, right? Because people need information to do their job. So we got to make sure that we always have some kind of networking ability, right, to access the information, which is, again, availability. In the second bullet point, we have non-repudiation. And non-repudiation is basically when let's say I send you an email again, and maybe I said something really mean in that email. You took it to HR, and then you said, look, Lee sent me this email. If I denied it, right, I could basically say, hey, that wasn't me. Somebody must have hacked me, or somebody must have been impersonating me. Well, non-repudiation, because we have digital certificates that say you are who you say you are, non-repudiation basically says you can't deny that you sent this message. So that falls again along the integrity line, right? So they could hold me accountable for the things that I say because of non-repudiation. And we have systems in place like those digital certificates to enact that principle. All right. Then if you look at the next bullet point, so this is just me right now going off of what I've known from the last test. Um, Things that I do not remember as well, I'm going to Google. All right, so moving on to AAA: authentication, authorization, and accounting. When you think about authentication, right, you think about the concept of authenticity, right? Are you who you say you are? Like, for example, if I'm again sending an email, how does the sender, how does the receiver know the sender is who they say they are? How do you know you're actually talking to the website that you intended to go to? Maybe it's just a spoofed website. Maybe somebody made a copy of it and you didn't even know. Um, so authentication is basically verifying that you are who you say you are. Now, when we have authorization, we talk about access levels, right? So we're talking about, um, let's say we have security clearances, right? There's levels of access that you can have if you're authorized. So maybe you have a secret clearance, but you're not able to see anything that's top secret. You would only be able to see things that are confident at a confidential level and a secret level, but you wouldn't be able to see the top secret things because you don't have the authorization, right? Or if we talk about in a network, right? Let's say we have a finance department and then we have an engineering department. The people from the engineering department should only need access to what's in the engineering department folder. They shouldn't be authorized to access the stuff in the finance folder. That wouldn't make sense, right? So the concept of authorization keeps everybody from accessing things that they don't need access to. I'm going to talk a little bit more about that. It's a concept called principle of least privilege, where you make sure people only have the access to things that they need and nothing more. All right. So then the last A would be accounting. So holding people accountable for the information that they access, right? So let's say you authenticated, you verified you are who you say you are. You got authorized, so now you actually do get into this top secret finance folder. And now you need to be held accountable for the information that you used while you were in that folder, if that makes sense. So let's say I pulled out a certain file. I need to be held accountable for the things that happened with that file. And we have certain mechanisms that we can implement in IT to hold people accountable for the information that they use. All right. So again, they have another section when they talk about authenticating people. So there's a lot of different ways to authenticate people. If you ever heard about the concept of two-factor authentication, it's when you use multiple methods to verify somebody is who they say they are. So for example, with two-factor authentication, they may ask you for a password initially and your username. So let's say I put in the username CoolIT. I then need to put in the matching password for that user. But then when I put in that password, they also send me an email that gives me a code that I also need to put in. I'm sorry, that wouldn't be two factor. Let's say um they ask me for my password and then they ask me for a fingerprint or something or some kind of token, right? Maybe they sent me a digital token and I used that combination of credentials to actually authenticate and verify I am who I say I am. So that would be something that you know, which is your password, and then it would be something that you have, which is that token. And sometimes your phone itself is that token. All right. There's a lot of different ways to give people tokens too. And we'll get into that. Then you have authenticating systems. right? So maybe it's not a person, maybe it's some robot or some kind of service that needs to get authenticated, right? Some kind of process that needs to run needs to be authenticated as well. And there's ways that you can do that and store credentials for those services. So, for example, um, maybe I have a certificate authority, and in order for us to actually authenticate that certificate authority, we use its digital or root certificate. The root certificate will have these things on it called a private key and a public key pair. The private key is what we would use to actually say, okay, yeah, we see he signed it with this private key, and it also matches his public key, so we can say that this CA is trustworthy. All right. Or we might have a service, right, that needs a digital certificate. It's not a person, so it can't just give it a password, right? Maybe you need to just give it a digital certificate that it can use to authenticate. So like a driver's license or something. If you think of it in that way, it's basically a driver's license to access information. Then we have authorization models. So when I took the test, I think I took the 601 or the 501, which was two exam topics, or I'm sorry, two exam versions ago. So I'm gonna have to look up what authorization models are. So what are authorization models according to CompTIA Security Plus? And again, guys, I'm just Googling this right now because if I were to read from some of the books that I have, it could be copyright infringement. So I'm just doing this as a safe way to share the information. So feel free to challenge anything that we're talking about. And again, anything I don't know, I'm just going to try and Google and figure it out as well. So according to CompTIA Security Plus, authorization models determine user access based on predefined rules and include discretionary access control, DAC, mandatory access control, MAC, role-based access control, RBAC, attribute-based access control, ABAC, and rule-based access control, RBAC. So it's two RBACs. That can get a little confusing. And then it says DAC, which was discretionary access control, is the most flexible, allowing resource owners to manage access, while MAC is the most restrictive. So it would be mandatory access control. So remember when we talked about that principle of least privilege, where only people that need access to certain systems get access to it and nobody else, and um, no more permissions than they need, we're talking about mandatory access control. Using security labels and clearances to control access. So again, mandatory access control is the most restrictive type of access control, and it uses security labels and clearances to control access. So you may, again, we talked about people who have security clearances. There's levels to it, right? So the first level, I think, is uh, public trust, and then it becomes confidential, and then it becomes secret, then it becomes top secret, and then it becomes special compartmentalized access. So yeah, those are the different uh, security clearance access levels, at least in the U.S. Um, and then what we're talking about, DAC, which is the most flexible, allowing resource owners to manage access. Right. So maybe I have created a folder, and I can determine myself who's going to have access to this folder. So I have a little bit more granularity and control over that folder. Then we said we already talked about MAC, RBAC, which grants permissions based on a user's role. And ABAC uses attributes of the user, object, and environment. And rule-based access uses a set of predefined rules to determine access. This is a lot, but we're going to make sure that we go through each of these concepts again in another video. We're going to try to tighten up on each one of these as we go through it. So let's just take a look back at this. All right, so we're probably going to distill down in another episode specifically about these different types of access control. Let's come back here. And let's talk about gap analysis. What is gap analysis according to CompTIA? So, according to CompTIA Security Plus, a gap analysis is a process of comparing an organization's current security posture against the desired security state to identify weaknesses. This desired state is often defined by internal policies or external standards, and the analysis creates a roadmap for improvement by highlighting deficiencies in policies, controls, and processes. The goal is to pinpoint where security is insufficient and to develop a plan to bridge those gaps. So, a gap analysis basically saying you got a gap in your security environment and you need to fill that gap before you get hacked. Long story short. All right, and there's a lot of different ways and industry standards. For example, like the National Institute of Standards and Technology (NIST), they could give you security requirements that you have to meet in order to get the stamp of approval and run your operations. Right. So let's say you're still using Windows XP. That's a big. Nobody should be using that. I don't even think it's usable at this point. Let's say Windows 7, right? Or Windows 10. If Microsoft has stopped supporting Windows 7, that means you no longer get updates. And there are a lot of security vulnerabilities that you will have in your environment. This is why you have to constantly update your systems. And if you don't make a policy for those updates, you will just be at the mercy of a hacker, right? Because let's say you miss an important iPhone update. Maybe it was a security update. And the hackers have found a new way to get into the phone, which would be a vulnerability. Because you missed that update, they can still get into your phone. So that's why Apple sends out updates every so often, or at least that's what they say, right? And Microsoft does the same thing. They have something called Patch Tuesday, where they'll send out updates every so often that improves the security through code, right? So you need plans, right, to actually implement this gap analysis. Like, so once you actually figure out where the gaps are and you analyze your network, you need to come up with a plan and schedule. So, like, you need to figure out when everybody can come together and hit all of these different computers in the network. And you need to figure out if you can do these off hours so that this update doesn't potentially break systems that you already have in place. Right. So sometimes these big software providers make mistakes, and when they push the update out, it can cause all of the systems for the customer to crash. You don't want that to happen, so you try to plan for it to be off hours so that you can roll back if needed. Right. So we'll get into that later. All right. Zero trust. Let's talk about zero trust. It's an important security concept. What is zero trust according to CompTIA Security Plus? And again, y'all, I'm gonna keep saying this. This is all based on Google AI's interpretation of it. I'm trying to explain it as I go, but I'm going to go back and do my own research as well through my books and notes that I've taken in the past and make sure that this information is correct. And then I'll go back and I'll distill down on each of these concepts in separate videos. Zero trust, according to Google AI, is a cybersecurity strategy that assumes no user or device is trusted by default, regardless of their location inside or outside of the network. This model requires continuous verification and strict access controls for every user, device, and connection before granting access to resources. The core principles include never trust, always verify, enforcing least privilege access, and using methods like microsegmentation and multi-factor authentication to limit vulnerabilities. So let's talk about the core principles: never trust, always verify. So every entity must prove its identity every time it requests access, with verification occurring continuously based on real-time risk assessments. So there are certain networks that don't allow you to just hop from resource to resource without verifying you are who you say you are. The ways around this to make these processes quicker or more productive is to use digital certificates. The digital certificate, again, is basically your driver's license for accessing information over a network. And that driver's license or digital certificate would be made up of a public and private key, right? That you can use to verify you are who you say you are. So you would use the private key to sign your certificate, and then you would use your public key along with the certificate to actually verify that it's you, or use it as your badge in a way. Least privilege access. So we talked about principle of least privilege. Users should only be granted the minimum level of access needed to perform their specific job functions. This keeps people from being bad actors. It keeps them from it just keeps the world from getting crazy and getting your network from being exposed to bad actors. So sometimes people take advantage of access levels and leak information that they shouldn't have. So let's take it out of like the corporate world. Let's talk about like just music, right? Like your audio engineers may have access to your album. Well, just because they're your audio engineers doesn't mean they should always have access to that information. So you may restrict them from actually taking that music with them outside of that studio. Okay, so that your music doesn't get leaked, because these artists spend a lot of money to get album sales, and if you leak the album early or you leak it for free, it kills their album sales. Okay, so you can think of it in that way. Then let's talk about microsegmentation. So network parameters are broken down into smaller isolated zones to maintain separate access controls and limit the potential impact of a breach. So let's say you have a company and you break that company up into different parts. So you might have finance in one part, you might have engineering in another part, you might have HR in another part, you might have uh, marketing, right? So you have to segment the access that these different departments need into little pieces. You have to really give them all special attention and special access, right? So that you're implementing the principle of least privilege. You're only giving them the information that they need. Somebody in the marketing department shouldn't be messing around with my robot information in the engineering department. Somebody in the engineering department shouldn't be messing around in the finance department, trying to give himself a raise or something, or expose how much another employee makes compared to them. You don't want that happening, so you need to separate their resources from each other. And then the ways to implement this zero trust strategy. Oh wait, we don't want to dive deeper. Let's go back. Not right now. We talk about multi-factor authentication, so requiring more than one form of verification, as single-factor access is not considered secure. So when you log into a website and they only ask you for your password, it's secure, but it's not that secure, because if somebody gets your password, game over. Now, if we add another factor to that, it's much more secure, right? You just doubled your security. So maybe they got your password, but if they don't actually have that token, which would be your phone, right? You get a text message or a code to your actual phone, then they can't hack you, right? You might get a security alert saying somebody tried to access this account from Timbuktu or something like that. And because you have the actual phone that they sent the code to, that hacker couldn't get in. So that's the purpose of multi-factor authentication, MFA. Then we talk about adaptive identity and access control. So access is granted based on a dynamic evaluation of risk, considering various parameters like user location, device type, and more to create stronger authentication. So let's talk about like geolocation, right? If I work in Baltimore and my office is in Baltimore, and I usually log in from Baltimore, then I if a hacker tries to log in from Egypt, we should get some kind of security message saying, "Hey, your account, somebody's trying to log into your account from Egypt, and you normally are in Baltimore, so you need to check on that and make sure that your password didn't get leaked." Okay, so because you have the actual token, which is in Baltimore, that person in Egypt, even if they got your password, can't get in. Okay. All right. So then let's talk about security controls. Then security controls, like implementing additional security controls, such as encrypting data both in transit and at rest. It is crucial for a zero trust environment. So let's talk about data in transit. So when you send information, it doesn't just magically pop up on the other person's laptop or phone. It actually has to go from a internet access point to your router, which then goes out to uh, the wires across the world or the country, and they move through different computers and different devices before it gets to the next person. So it's not going straight to the other person. It's going through other computers and other networks to get to the other person. Okay. So when it's actually being sent to the other person, if it's not encrypted, everybody that information touches could read that information, and that would make it insecure. And then they could touch it. They could manipulate the information. They could do whatever they want with it. So to solve that problem, we came up with encryption. So encryption is when we use those public keys that we talked about earlier. We use those public keys to scramble the message in a mathematical way that only the people involved in the conversation can read. Okay. So let's say I use my public key and I lock the message. I scramble the data. When I send it to the other person and they get it, let's say that person sent me their public key. Let's do this right. So I want to have a conversation with my wife. So my wife is going to send me her public key, right? And then I'm going to send her my public key so that we can scramble the information before we have the conversation. So for example, if she sends me her public key, I can use her public key to scramble the information. And because she has the corresponding private key that got generated with her public key, she can unscramble that information. I hope that made sense. It takes a while to get it. And also because I sent her my public key to scramble the information she wants to send to me. When she sends me that information, I can now descramble it or uh, decrypt it with my private key. All right. So take your time on that concept. We are going to revisit it, but that's a security control that we use to protect our information when we're sending it across the network. All right. 30 minutes in. Hopefully, we'll get through all of this. I only want this to be an hour, but we'll keep on going. Control plane. Let's talk about the concept of a control plane. What is a control plane according to CompTIA Security Plus? According to CompTIA Security Plus, the control plane is the part of a network or security device that makes decisions about how to handle data. It is the brain of the network, responsible for functions like building routing tables, managing network policies, and executing security rules. In contrast, the data plane is the part that actually forwards the data packets based on the decisions made by the control plane. So then you can think of it, I guess, as the brain and then the brawn of the body of the network, right? Key functions of the control plane that determines the path data should take across the network. Routing decisions. So if you know anything about networking, or if you just have internet in your home, you know that you have a router. When your router needs to send your information out, it makes a decision on which route it's going to take. So let's think of a mail carrier, for example. If I need to send a message to somebody, I would mail it, and then the mail carrier would decide which route it's going to take to get to that person's address or the receiver's address. Routers do the exact same thing in networking. But then you have policies. So you have to set and enforce security policies for access control, right? So again, we talked about what is the policy when somebody leaves. Let's say somebody gets fired from their job. There should be an access policy or some kind of offboarding that happens so that they don't have access to our network and our resources anymore when they leave the company. Let's talk about configuration. So, managing the overall network configuration operations. So, actually going in and configuring all these devices. If we're going to be using email, we need to send email over port 25. If we're going to be sending website or web traffic, we need to be open in port 443 so that we can encrypt our information as we're accessing these websites. Then decision making is part of the control plane, right? So then if you need to make a decision, such as forwarding or blocking or translating network addresses, so you can configure devices to block certain IP addresses coming from malicious actors or countries that you don't approve of, right? So you can and then you can tell these devices which route you want them to take, which protocols you want them to use, et cetera, et cetera. Example in a zero trust architecture. In a zero trust model, the control plane is crucial for implementing policy driven access control and threat scope reduction. So we talk about threat scope, we talk about how much of a threat is present in my network. We want to reduce that threat by implementing all of these different access controls. So we need to do a gap analysis. We need to keep looking at our network in a security. We need to keep examining our security posture of our network. Yeah. So I think that's enough on that part. Let's talk about adaptive identity. What is adaptive identity? According to CompTIA Security Plus. According to CompTIA Security Plus, adaptive identity is a security approach where the trust level of an identity is continuously evaluated And additional identification factors are added to create a more robust and dynamic authentication process. This is a form of adaptive or risk-based authentication, which uses contextual information like user location, device, and behavior to dynamically adjust security measures rather than using single static set of rules. All right, so let's break that down. So let's say, again, between 9 and 5, right? If all of a sudden it's my network sees me trying to log in from California or Canada or France, just like all these different places, it's going to start if we have the adaptive identity principle being implemented correctly. My network should shut that down. It should be like, hey, something weird is going on. Lee normally logs in between 9 to 5 from Baltimore, but now he's at 3 a.m. trying to log in from Japan. That's not happening, right? So you want to make sure that even though you set you set rules that examine these types of things, so that let's say I do go to Japan, right? If I let my company know in advance, then they can allow a certain they can allow certain login to happen because I gave them a heads up. So it's not just like, oh, you can't go to Japan. You just have to give us a heads up before you go to Japan. Or at least that's how I think of it. Okay. So if you don't think of it like that, feel free to challenge it. Leave a comment. Tell me what you think adaptive identity is. And also, like and subscribe. Okay. So let's talk about threat scope reduction. So reducing the risk that you're taking in your network. What is threat scope reduction? Threat scope reduction is a control that limits user access to only the resources they need for the specific task. So, guys, you're going to keep hearing over and over the same things in different ways. All right. So, you're always going to have that principle of least privilege. You're going to be making sure that, people only have access to information that they need, nothing more, nothing less. So, we're just going to say that it reduces the attack surface. When we think about the attack surface, is all of the different points in the network that an attacker could hit. Okay. So that's the surface. You want to reduce that surface. So maybe they can only hit one device instead of 19 devices or however many devices are in your network. You only want them to be able to hit one. And if that one starts to act weird, we can shut it down and we can take it off the network and we can figure out how to stop the hackers. All right. So think of that. And you have policy driven access control. Let's talk about that. What is, oh shit. What is policy driven access control? Policy driven access control is a method that uses predefined policies to determine user access to resources, considering a combination of attributes like the user's role, the resource's characteristics, the requested action, and contextual factors such as time or location. Unlike models like RBAC, role based access control, which are based on predefined roles. PBAC makes dynamic real time decisions by evaluating these multiple attributes against a set of rules to grant or deny access. So we talked about this already, right? I already gave an example of, I work in Baltimore, I work from 9 to 5 usually. Um, if my network determines that I'm working somewhere else or trying to log in from a different time, different place than the usual, they'll pick up on it and they will make a dynamic decision to shut down access until I verify what's going on. Okay. Policy administrator. So you can think of that, I think, is like a system administrator, where they actually go in and administer all the policies. So what is a policy? What is a policy administrator according to Security Plus? According to Security Plus, a policy administrator is a component within a zero trust architecture that acts as a liaison between the policy engine and the policy enforcement point. It is not a job title, but a function of the system that manages and communicates access policies to enforce them. This role is distinct from a human security administrator who is responsible for implementing and managing an organization's overall security systems and policies. Huh, interesting. The policy administrator in a zero trust model. The zero trust model, which is covered in the Security Plus exam, operates on the principle that no user or device should be trusted by default. The policy administrator works within this framework to facilitate access control decisions. Its key functions include communicating with the policy engine. So the policy administrator sends a user's access request to the policy engine. The policy engine then makes a decision to grant or deny based on those predefined policies. So let's say, I'm a new hire and they say, hey, we need to get Lee Douglas access to something. It sends that the policy administrator will send the access request to this thing called a policy engine. And the policy engine will say if they have all of the necessary credentials, we'll give them access. If they don't, we're going to deny access, and we may tell you why, we might not tell you why, but it's going to do its job as far as making the decision to grant or deny. Providing policy information. After the policy engine makes a decision, the policy administrator sends that information along with any necessary credentials like access tokens to the policy enforcement point. And then managing access policies. This component is responsible for establishing and managing the access policies that the policy engine uses to make its decisions. All right, and then we'll talk again about what the policy engine is. What is a policy engine? According to CompTIA Security Plus, a policy engine is a component that evaluates access requests against a set of predefined security policies to make a decision on whether to grant, deny, or revoke access. So one part of it, the policy administrator sends the user access request. The policy engine actually makes the decision to grant access or deny access or take away access. So sometimes you have things in the network called a certificate revocation list or CRL. So we talked about those digital certificates. Sometimes those digital certificates will expire and your policy engine will revoke that access through the form of a CRL, or they'll use the certificate revocation list to make that decision. Okay, and then they'll actually enforce that decision using the policy enforcement point. So it's three parts to it: policy engine, policy administrator, and policy enforcement. All right. All right, let's talk about the data plane. Talked about the control plane concepts, and now we talk about the data plane. What is the data plane according to CompTIA Security Plus? According to CompTIA Security Plus, the data plane is the part of a network device that handles the real-time forwarding and processing of data packets. So when we send information, we send it in the form of these things called packets. So you don't send all the information at once. You break it up into these little things called packets. And then you attach your IP address and other information to these packets so that they get to the right person and in order. Well, sometimes in order. All right. So your networking device is the device that actually makes decisions on where these packets go. Right. So it handles that. It's the workhorse of the network. So your router, your firewalls, all those things work together to make up the data plane. It is the workhorse of the network executing decisions made by the control plane by moving traffic, performing functions like network address translation and encryption, and enforcing security policies through tools like access control lists. So let's say a bunch of engineers sit around, and they're cybersecurity engineers, and they think about ways to secure the network. They come up with the policies. All right. Then they decide which policy engine they're going to use, what policy administrators. They basically think of all the algorithms that they're going to use, how they're going to get things done on the network. Then they actually configure those network devices to implement the policy. So they bring the policies to life. So the data plane is the part where you use you control the information, but the control plane is where you actually come up with the policies for controlling that information. All right, key function of the data plane: packet forwarding, policy enforcement, data processing, security enforcement. So again, the control plane is the brain of the network. It makes the decisions, determines the paths you're going to take, and builds the routing tables. The data plane is where actually the data is moving. So it's like the veins of the network. Then you have the management plane, which is the interface used by administrators to configure and manage the device using secure shell or SSH or APIs, application programmable interfaces. So either one of those tools can interface with the networking devices on the network, okay, so that you can configure this stuff. All right, implicit trust zones, implied trust zone. Think about implicit, we think about implication or implying something is trusted. So an implicit trust zone, according to CompTIA Security Plus, is a network segment where trust is assumed by default and access is granted without requiring continuous verification for every activity. All right. So instead of me checking to see if you have your credentials every time you want to do something, we can have a policy where it is implied that you are trusted. So it's not the zero trust model in this instance. It is implied that you are trusted. Okay, you said you are who you say you are. We're just going to trust you. You can have access. It all depends on how sensitive that information is. Now, we talking about people's security, social security numbers, and health information. You need that locked down. Can't have, uh, you can't have implicit trust in those kind of networks. You will have zero trust in those kind of networks. We need to make sure that only Lee Douglas is seeing his health information and nobody else. All right. So, for example, a physical office network might be treated as a trusted zone. So let's say if I had the credentials to get into the building, then I should be trusted to use the VPN or access resources on it. When I plug my device into the Ethernet cable at that office, I'm now implicitly trusted. Okay. So you can have location based trust. So if I work in Baltimore, I can get access to the Baltimore resources. We have assumed trust. So the certain devices that we use, if it has a certain stamp of approval, it can be trusted. Yeah, reduced friction. This model provides a more convenient user experience because it requires less frequent authentication. So not having to put in a code twice or 3 times, 4 times just to get access to information. And but it is excuse me, it is a security risk. A major security risk is that if a malicious actor gains access to one of these implicit trust zones, they can just get it. They can do whatever they want. So just because you live in Baltimore, don't mean you ain't a dummy. You know what I'm saying? Don't mean you won't go dumb. You won't go ham on the network. So we got to do a little bit better. We got to lock things down. Contrast with explicit trust. And in a traditional implicit model, a user is trusted once they are inside a specific network. With explicit trust, which is fundamental to zero trust, you require constant verification. So it's a slower process to get to the information, but it's more trustworthy, it's more secure. Wow. So we are already on 50 minutes, and we still have another section to go to. So I'm going to do a part 2 of this tomorrow. Stop right here at implicit trust zones. I'm going to go get something to eat, drink some water, come back with a fresh mind, and I'm going to try to make better notes as I go through this. But I'm enjoying this. I hope you did too. And I hope you learned something today. Continue to study on your own. If you join, please comment, like, and subscribe. Let us know what you think about each one of these topics, how we're doing, things we can do to improve the stream. And have a blessed day. We got you.